Amidst the battle against bacterial infections, aminoglycoside antibiotics emerge as powerful weapons, disrupting microbial protein synthesis and striking at the heart of the enemy. But as they wage war within the body, their potent effects bring both salvation and peril, unravelling a delicate balance between healing and harm. What are aminoglycosides? Aminoglycosides are a class of antibiotics that are used to treat various bacterial infections. They work by inhibiting bacterial protein synthesis, ultimately leading to bacterial cell death. These antibiotics are effective against a wide range of bacteria, including both gram-positive and gram-negative organisms. Some common examples of aminoglycoside antibiotics include gentamicin, amikacin, tobramycin, and streptomycin. They are often used to treat severe infections such as those caused by Pseudomonas aeruginosa, Escherichia coli, Klebsiella pneumoniae, and Staphylococcus aureus. Aminoglycosides are typically administered intravenously or intramuscularly, although some formulations can be given orally for certain infections. These antibiotics are known for their potent bactericidal activity but can also have significant side effects, including nephrotoxicity, kidney damage, and ototoxicity, hearing loss. Therefore, the use requires careful monitoring and consideration of potential risks and benefits. Summary: aminoglycosides are a class of antibiotics used to treat various bacterial infections. They work by inhibiting bacterial protein synthesis, leading to bacterial cell death. Common examples include gentamicin, amikacin, tobramycin, and streptomycin. They are effective against a wide range of bacteria but can have significant side effects, such as nephrotoxicity and ototoxicity. Aminoglycosides are usually administered intravenously or intramuscularly and require careful monitoring due to their potential risks. Here are some keywords and their meanings based on this content. 1. Aminoglycosides. Aminoglycosides are antibiotics that inhibit bacterial protein synthesis. 2. Bacterial infections. Bacterial infections are infections caused by bacteria. 3. Gentamicin. Gentamicin is a specific type of aminoglycoside antibiotic. 4. Protein synthesis. Protein synthesis is the process by which cells build proteins using genetic information. 5. Bactericidal. Bactericidal means having the ability to kill bacteria. 6. Nephrotoxicity. Nephrotoxicity is toxicity that affects the kidneys. 7. Ototoxicity. Ototoxicity is toxicity that affects hearing. 8. Intravenous. Intravenous is the administration of substances directly into a vein. 9. Intramuscular. Intramuscular is the administration of substances into muscle tissue. 10. Monitoring. Monitoring is keeping track of patient responses and potential side effects during treatment. Here are some questions for you based on this content. 1. Question: what is the mechanism of action of aminoglycoside antibiotics? 2. Question: which types of bacteria are aminoglycoside antibiotics effective against? 3. Question: can you name some common examples of aminoglycoside antibiotics? 4. Question: what are some potential side effects of aminoglycoside antibiotics? 5. Question: how are aminoglycoside antibiotics usually administered? 6. Question: why is careful monitoring necessary when using aminoglycoside antibiotics? 7. Question: what is the significance of gentamicin in the realm of antibiotics? 8. Question: what are the implications of aminoglycoside antibiotics being bactericidal? 9. Question: can aminoglycoside antibiotics be administered orally? 10. Question: how do aminoglycoside antibiotics affect bacterial cells? Here are some questions and suggested answers based on this content. 1. Question. What is the mechanism of action of aminoglycoside antibiotics? Suggested answer. Aminoglycosides inhibit bacterial protein synthesis, ultimately leading to bacterial cell death. 2. Question. Which types of bacteria are aminoglycoside antibiotics effective against? Suggested answer. Aminoglycosides are effective against a wide range of bacteria, including both gram-positive and gram-negative organisms. 3. Question. Can you name some common examples of aminoglycoside antibiotics? Suggested answer. Common examples include gentamicin, amikacin, tobramycin, and streptomycin. 4. Question. What are some potential side effects of aminoglycoside antibiotics? Suggested answer. Potential side effects include nephrotoxicity, kidney damage, and ototoxicity, hearing loss. 5. Question. How are aminoglycoside antibiotics usually administered? Suggested answer. Aminoglycosides are typically administered intravenously or intramuscularly. 6. Question. Why is careful monitoring necessary when using aminoglycoside antibiotics? Suggested answer. Careful monitoring is necessary due to the potential risks of nephrotoxicity and ototoxicity associated with aminoglycoside use. 7. Question. What is the significance of gentamicin in the realm of antibiotics? Suggested answer. Gentamicin is a widely used and important member of the aminoglycoside class of antibiotics, known for its broad spectrum of activity against bacteria. 8. Question. What are the implications of aminoglycoside antibiotics being bactericidal? Suggested answer. The bactericidal nature of aminoglycosides means they directly kill bacteria, making them effective against severe infections. 9. Question. Can aminoglycoside antibiotics be administered orally? Suggested answer. While most aminoglycosides are administered intravenously or intramuscularly, some formulations can be given orally for specific infections. 10. Question. How do aminoglycoside antibiotics affect bacterial cells? Suggested answer. Aminoglycosides disrupt bacterial protein synthesis, which is essential for bacterial growth and survival, ultimately leading to bacterial cell death. This material primarily helps to learn English vocabulary, English grammar, and English sentence structure. Thank you for watching. Thank you for thinking about subscribing to see various exciting videos.